Hello everyone, welcome to the 17.4 Geo Group Outlook. My name is Sampath Ranasinghe and I'm the product manager for the group. So let's get started with our first major initiative in this milestone, which is unified backups. A little bit about unified backups. Unified backups is the next generation of backup solution for backing up GitLab. The current solution has a number of limitations, scale being one of the key limitations, but also the fact that it has several pieces to it. It has different offerings across the different deployment types and different capabilities there. So unified backups, as the name implies, is to build a single solution that works across all of our GitLab installations. That's Linux package, Docker, Cloud Native Hybrid, and source code. Um, it's also intended to power the backup for our SaaS offering. So that's gitlab.com and GitLab Dedicated. So far, we've been working on the creating the MVC, the foundations for the backup solution, which was focused on the 1K Linux packaged deployment with local file storage. We've run into a number of permission issues that we've been tackling, and we have an internal deadline to support cloud native hybrid environment. So therefore, we have decided to pause the work on the Linux packaged 1K support, 1K architecture support, and shift our focus to the 10K cloud native hybrid reference architectures on GCP. We can still use a lot of the work we've done with previously, but we will be focusing on what's required to deliver the backup in a working fashion for the cloud native hybrid environment in this milestone. Next up is org mover MVC to be precise. GitLab.com's architecture is changing. We are building, we want to GitLab.com to scale horizontally, and we want to be able to have an architecture that will support that. And the architecture that we've chosen is called cells, where the customer data is sharded into shell cells, each customer being allocated into a particular cell, allowing us to have self-contained components called cells that can be that's essentially a fleet of cells that ultimately forms GitLab.com and allows us much more room to scale horizontally. In order to be able to support this architecture, we also have the concept of organizations, and this is where an individual customer and all of their data can be encapsulated into an entity called an organization. And as part of the organizations, we need to be able to, as part of operating cells, we need to be able to move these organizations between cells. And this could be for load balancing reasons. This could be for example, moving an organization, a customer from our existing monolith, GitLab.com monolith, to a secondary cell, which is based on the new cells architecture. So we are going to focus on moving existing customers, existing organizations, ultimately from the GitLab.com monolith, or what we will call cell 0, to a secondary cell with the org mover MVC. In order to do this, we have to rely on some of the technologies that the Geo product has in order to replicate the customer's data from cell 0 to a secondary cell. As part of this effort, what we are doing in this milestone is to make and we're gonna make progress on this, is to make Geo Postgres replication technology agnostic. This means we've looked at technologies such as logical replication, and also talking to the primary cell database in order to facilitate moving data, moving the other data, not Postgres data, but repositories and object storage data. So facilitating that by talking directly to the Cell Zero's Postgres database rather than working off of a streaming replica. Why? Because streaming replication requires that you replicate all of the database. And when we want to move a single organization, a single customer, streaming replication really doesn't work in this. Logical replication allows us to filter a very specific set of data and move only that data to the secondary cell. So this is the premise behind the investigation into logical replication. We are also looking at backing up the organization specific data on the database and copying that over to the secondary cell. Why this is important is because logical replication or enabling logical replication adds an additional load on wall disk I/O throughput because it adds additional data to the wall logs. We want to avoid this, at least initially, given we are running quite quite close to the capabilities there. So therefore, we want to avoid adding more load onto the wall disk I/O throughput right now. And so therefore, what we are planning to do is pack up the database content related to a single organization and move that manually to the secondary cell. So that's phase one. That's org mover MVC, and then org mover phase two will involve implementing Postgres logical replication. There's some pre-work we need to do in order to support this. Anybody watching that's deployed Geo will appreciate that when you turn on Geo, when you attach a secondary site, we will start to checksum the primary site's data. And in most cases, the checksumming process reveals data inconsistencies. What do these data inconsistencies look like? They look like orphaned database records or orphaned files. And therefore, either there's a database record that we can't checksum, or there's a file that doesn't have a database record, so it can't be referenced. And obviously, Geo wants to ensure that all the data is copied correctly, and so that the data integrity and the consistency on the primary is important so that we can match that on the secondary. Similarly, all the principles that apply to Geo apply to org mover. And so we want to begin the rollout of the checksumming process on gitlab.com. This will be a gradual rollout where as the rollout progresses, we will begin to see data inconsistencies and we'll begin resolving those data inconsistencies. This is all done in preparation for org mover MVC itself, where we will begin to move organizations from cell zero to a secondary cell. And then lastly, we are aware that GitLab is deprecating support for CentOS 7 in GitLab release 17.6. And we will this will encourage customers to upgrade to newer operating systems. CentOS 7 contain glibc 2.27, and all later glibc versions, 2.28 and later, have changed the locale data and how it manages the locale data, how it creates the locale data. And so as you upgrade, the Postgres indexes will get corrupted if you upgrade in place. And this also applies to Geo. And we want to ensure that customers have a safe transition as they upgrade their operating system. And the effort here will be to document the best practice for upgrading your operating system, where a glibc update from 2.27 to something later, version later, is involved, so that your GitLab and your GitGeo site remain available and up after this upgrade. And then we have some various different documentation updates and some miscellaneous items where we're addressing bugs. Thank you for watching. Look forward to seeing you next time. and hope you enjoy the update.